All right, so another day, more, all right, systems of equations. Now, we're going to learn a second algebraic method to solving systems of equation. This one is a little bit cleaner in the fact that we won't have to necessarily solve for x or y, and you'll see that in just a moment. So now, we don't have a typical opener for this, but I am going to have you do a little bit of a review here. So you can see we're doing systems with something called elimination, all right, and that's topic 3 in standard 12. So here's what I want you to do. I want you to graph these two lines and, all right, as the opener, and tell me, find where they intersect, and then I'll show you how elimination works with those two equations. So go ahead, pause the video, do that, and I will see you in just a moment. All right, so when we look at what we have here, hopefully this is what you came up with as well, that they intersect at the point 2, -3, right? Because if I found my x-intercept here, 3 times 1, all right, is 3, and then y equals 3, so that would be our first line right here. All right, then if I find my x-intercept here, right, -3 times 4 is -12, so there's your x-intercept of 4, and then if I cover this up to find my y-intercept, because x is 0, 2 times -6, all right, is -12, so right here. So you can see, all right, that that's where they intersect. Now, why is this called elimination? All right, and what we want to do is we're going to stack our two equations on top of each other, and we always want the variables to align. So we want all the x's in one column, we want all the y's in one column, we want all the numbers in one column. Now, that's kind of the way things are written right here, but if it's ever not, you should write it in order, but let's stack them. So 3x plus y equals 3, and then -3x plus 2y equals -12. Now, it doesn't matter which one's stacked on top or bottom, right? We'll get the same answer either way. Now, the reason why it's called elimination is what we want is we want one pair of variables, either the x's or the y's, and once again, it does not matter, all right, and sometimes it's more obvious than others. We want them to be opposite coefficients so that when we add them, once again, we're using that zero property. We want to eliminate them. We want them to equal to 0. So when you look at what we have right here, all right, you can see that naturally we have these as opposites right here. So notice if I add these two equations together, 3x and -3x is 0. They have been eliminated, and that's the goal here. All right, and then I have y plus 3y, or sorry, y plus 2y, which is 3y. All right, and then I have 3 plus -12, which is -9. And so notice, now we're to a very simple problem to solve, right? So 3 times something is -9, right? 3 times -3 is -9. So y equals -3. So notice how much cleaner that is, right? Like we can just stack it, add them, all right, and get to that number. But now that's if they are already opposites. Now they're not always that way. Now, once again, we can see, right, that we're doing a systems of equations problem. So we know to get both the x value and the y value for our point of intersection. So now notice we know y is equal to -3. So once again, just like we did before, I can go back and plug this in either for this y or this y. And once again, you get to pick. It doesn't matter. You will get the same value either way. But to me, this one looks simpler, right? So I'm going to say 3x plus y, right, is equal to 3. All right, now I want to make this equal to 0, so I'm going to subtract 3 from both sides. 3x minus 6 is equal to 0, right? What minus 6 is 0? And that would be 6, so 3x equals to 6. And then 3 times 2 is 6, and so we can see that there's our point of intersection, right? 2, -3. All right, so now let's move on to problem 2. Now, once again, I'm going to have you, all right, graph both lines here. Now notice this is -6x. The spacing's a little weird here, but this is -6x minus 6y. So I would like you, once again, pause the video, graph these two lines, find out where they intersect, flip the video back on, and we'll see how you did. All right, so hopefully for your first line, all right, you find your x-intercept, -6 times 1 is -6, all right? Find your y-intercept, -6 times 1 is also -6, so there you go, there's your first line. Now when we go over here, right, -10 times 3, all right, is -30, and then -6 times 5 is -30 right there. And then once again, I don't know if my lines are a little bit off or whatever, but we can see that we get to this point of intersection here. And on my graph, it looks like maybe about 5, -5, maybe 6, -5, somewhere in the middle there. Not real exact, right? So, all right, so let's look at, and maybe it is, right? Maybe it is a decimal, and now that's why we want the algebra part, right? So let's stack our equations. So -6y equals -6. -10x minus 6y is equal to -30. All right, so now, once again, what we want are opposites, right? So when we look at our variables, well, -10 and -6 aren't opposites. All right, so let's look at our y's. -6 and -6, they're very close, right? But they're not opposites, right? So the opposite, we want one to be positive and one to be negative. All right, so what that means is I can multiply one of them to make it a positive 6. And that's the trick, right? So if we don't have opposites, we're going to pick a multiplier to make it so. So notice, if I multiply this top equation by -1, all right, so I'm going to do -1 times -6, that's positive 6x. And I'm going to distribute this -1 to everything in this equation, so all three terms. So -1 times -6y is positive 6y. -1 times -6 is positive 6. Negative 10x minus 6y equals -30. I'm just going to bring that equation over because we didn't do anything to change it. So notice now, by multiplying this top equation by -1, right, I now have created a situation where my y's are opposites, and they will eliminate. All right, so 6y minus 6y, that is 0. That's the goal. Now 6x minus 10x, that's -4x. 26 minus 30, that's -24. All right, so there you go. And then notice this gives me x equals 6. All right, so there's the first half of my point of intersection. So yeah, so maybe my lines are drawn a little bit off. Once again, that's the disadvantage of, right, doing it with graphing, right? So you may not be as accurate as you could be with the algebra. All right, so now we have x, so we need to find y. So once again, I can go back and plug it into either equation. I'm just going to use this first equation here. All right, so -6 times x, which we know is -6, right? Like that. So I get -36 minus 6y equals -6. I'm going to get this equal to 0 plus 6 plus 6. So -30 minus 6y is equal to 0. All right, so -30 plus 30, right, is 0. So that means -6y is equal to 30. And then -6 times, all right, -5 gives me a positive 30. So notice that this should have been 6, -5. And you can see that that should have intersected right there. But if you're not real precise, and you can see kind of I missed the intercept a little bit there, right? So if you're not real precise, it can lead to, all right, an inaccurate graph, which then will lead to an inaccurate solution. And that's the advantage of the algebra. All right, the algebra will always give you the exact answer. All right, let's flip the page here. All right, and let's do, all right, one more together. All right, so let's look at 3a here. All right, so now, once again, we want to solve this system. We're not going to graph this time. We're just going to go right into elimination. And I'm going to stack my equation. So I'm just going to go 8x plus 8y equals -24. And I'm going to go with 3x minus 2y equals 6. All right, so the first thing I'm going to look for, let me get this back up there, just back in focus for you. Then I'm going to look at my variables, see if I have natural opposites. Well, 8 and 3 are not opposites. 8 and -2 are not opposites. All right, so now I have to make one of the pairs of variables opposites. And once again, it does not matter, right? So whether you pick the x's to make opposites or whether you pick the y's to make opposites, it'll give you the same answer in the end. All right, so now when we look at this problem, I'm going to make the x's opposites. All right, so what I'm going to do is I'm going to look at my coefficients. So I have an 8 here and I have a 3 here. And I want to find a number that 3 and 8 both go into. So notice if I count by threes, right? So 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, right? Okay, so that's counting by threes, right? Then if I count by eights, right? All right, 8, 16, and then I can stop at 24 because I want to get to the first number on both lists, right? So here's the 24 and here's the 24. So that's a common multiple of 3 and 8. So what I want to do is change this to positive 24x and negative 24x. So when I look at this first equation here, so if I have 8x, I want to make it a positive 24x, I need to multiply this entire equation by 3. All right, so let's do that. So 3 times 8x, that is 24x. Okay. 3 times 8y, that is 24y. And then 3 times -24 is -72. All right, so notice if this is negative, or just if this is 24x, all right, I want this to be -24x so that they will eliminate. All right, so now I'm going to come back to the second equation. Now, what do I have to multiply 3 by to get to -24? And that would be -8. So -8 times 3x is -24. That's what I want. -8 times -2, that's a positive 16y. All right, -8 times 6, that's a -48. And now I can eliminate this. So 24x minus 24x, that's 0. That's eliminated. 24y plus 16y, that is 40y. And then this is -120. And now I'm to that good position, all right, to where I can just solve here. So 40 times -3, all right, is my y variable. So that's half of my point, right? Okay, so I know that's -3 there. Now, once again, I have to have, all right, get that back into focus. I don't know why it keeps coming in and out on you. I have to have my x value. So once again, I can go back to my first equation or my second equation, and I can plug this y value in. I think the second equation is a little simpler, so let's do that. So 3x minus 2 times y, which is -3, equals 6. So 3x, and then this is plus 6 equals the 6. All right, get this equal to 0 by subtracting 6 from both sides. So 3x equals 0, and then 3 times 0 is 0, so x is 0. All right, so there's my point of intersection. All right, that is, all right, 0, -3. Now, here's what I'm going to do. I'm going to just copy these equations back down here. So let's look at 8x plus 8y equals -24. And let's look at 3x minus 2y equals 6. And you don't necessarily have to write this, but I want you to just watch the problem again, because once again, it doesn't matter which variables that I get opposite. So in the last example, all right, I just did the x's. This time I'm going to do the y's here. All right, and so now notice I have an 8 and I have a 2. So if I count by 8s, once again, like 8, 16, 24, right? Now if I count by 2s, right? 2, 4, 6, and then I can stop at 8. All right, so 8 is a common multiple, all right, of 2 and 8. Well, that works out really well because notice I already have a positive 8y here, so that means I don't have to do anything, all right, to that equation. I can just bring it down. Now, if this is positive 8y, I want my next equation to be -8y so that they will eliminate. So I want to change this -2y to -8y. And so what do I have to multiply everything in this equation by to make that happen? That would be 4, right? So 4 times 3x, that is 12x. 4 times -2, that's the -8y I wanted. And then 4 times 6 is 24, all right? Oh, man. Excuse me. All right, there we go. All right, so notice what happens, right? 8y and -8y, that is 0. That has been eliminated. 8x plus 12x, that's 20x. And then notice what happens over here. -24 plus 24, that's 0. And then 20 times what is 0? That would be 0. And so that's 0, right? So we said x was 0 in this problem. So all that happens, right, is the order in which you get your solutions. All right, so you're going to get the same answer in the end, but if you eliminate one versus the other, right, you might get the x first and then the y, or you might get the y first and then the x, and it doesn't matter because in the end, you will get the same values for those variables. And that is elimination. All right, and that wraps up our lesson for today. So if you have any questions, anything that doesn't quite make sense to you, right, clarify those in class, highlight them, write them down, make sure you ask those questions, and I will see you then.